All right, in this lesson, we're going to talk about the functions of logarithms and their graphs. So we can take logarithms, and if we put an x in the parentheses, and if we set it equal to y, now it becomes a function, and we say that this is a logarithmic function, where y, which would be the exponent, is equal to log of some base here of whatever's on the inside, whatever the product would be, okay? So this is what a logarithmic function looks like, and this is the graph of a logarithmic function. Now, you may notice that the x values here, there aren't any of them over on the negative side, and this is a vertical asymptote at 0, which means that the log graph never actually touches 0. So that means that the x values are all positive. And that means that x can never be 0 and x can never be negative. And one of the reasons for that is because you can never, here, let me write this out, you can never take the log of 0 or a negative number. So like if we tried to do log base 2 of, let's say, negative 4, well, there is no exponent. There is no exponent, so 2 to the k power equals negative 4. There is no exponent on 2 that would give us negative 4, okay? Similarly, we couldn't do log base 2 of 0 because there is no exponent that would give us 0 as an answer, okay? And therefore, we can never take the log of 0, and we can never take the log of a negative number. Now, we can look at this another way. If we reverse these two sides here, okay, so if we write it instead as log base b of x is equal to y, so watch what we do here. If we convert this into an exponential, if we take b to the power of y, let's do that first. So b to the power of y equals b to the power of y equals x. Okay, and you'll see what's happened here now. Look, we now have swapped. We have made the x the function value, and we have made the y the independent variable. Okay, and so when we do this, it causes the rewriting here, it rewrites the dependent variable as the independent variable, and it rewrites the dependent variable as the independent variable as the dependent variable. And so if you recall, when we swap x and y, we get an inverse. And so what that means is that exponential expressions are the inverses of logarithmic expressions, or a better way to say it is exponential functions are the inverses of logarithmic functions. And so we're going to look at that next. All right, so you can see here, this is the graph of an exponential function, this blue one here, okay? And this red one is the graph of a logarithmic function. This is the line y equals x, and you can see that the red one is a reflection of the blue one over this line y equals x, and that's basically what we get with inverses. You'll also know that this point right here, which is 2, 4, is a reflection of this point, which is 0.42. This point right here is 2, 1, and this point is, this point is 1, 2 right here, and this point is 2, 1. This point is 0, 1, and this point is 1, 0. And remember, with inverses, you swap the x and the y. 0, 1 becomes 1, 0. 2, 1 becomes 1, 2. 2, 4 becomes 4, 2. And so it is true that logarithmic functions are the inverses of exponential functions. And I want you to recall that the domain of an exponential function is negative infinity to positive infinity. And the range of an exponential function is from 0 to infinity. Remember that an exponential function cannot equal 0 unless you shift it, okay? And so log functions, when we do the inverse, the domain and range actually switch places. And so for log functions, the domain is going to be the range of the exponential. So the domain of log functions is 0 to infinity, and the range of a log function is going to be the domain of the exponential function, which is going to be from negative infinity to positive infinity, okay? And now what we're going to do is we're going to look at shifts and reflections of log functions and how they look on in the function itself. All right, so remember that the logarithmic function, the original logarithmic function, is log base b of x. Now x is, or b is going to be some number, okay? So like log base 2 of x, log base 5 of x. It could be ln of x because when it's log base e. And so there are a couple things we can have. So look here, this is a vertical reflection. This is a reflection across the x-axis. The original log function looks something like this, okay? And so what's happened is it's been flipped upside down, okay? And so now it looks like this, okay? Instead of going vertical down, it goes vertical up. And instead of sort of going off to the right and up, it goes off to the right and down, okay? So this is a vertical reflection. This is a reflection over the x-axis. And basically the way we accomplish that is we just put a negative on the log function. So if we take negative log base b of x, that's going to be, what that's going to do is that's going to flip it upside down, and it's going to be a vertical or a reflection over the x-axis. This right here is a reflection across the y-axis. Okay, you can see that because the original normally looks like this, and so what's happened is it's flipped sideways. Okay, it's flipped around this way. Okay, and so since the mirror is the y-axis, it's gone from this side over to this side. It's a reflection over the y-axis, and the way we accomplish that is by putting a negative on the x itself. So log base b of negative x would give us a reflection over the y-axis, okay? And now what about up and down shifts, okay? Well, an up and down shift is basically just something added on to the end, plus k or minus k. So the original function is just log base b of x, and we can do plus a number or minus a number. So this could be like plus 10, or this could be like minus 17, okay? So when you have log base b of x plus k, this is going to be an upshift. Plus means up. An upshift by k units. Minus k would be a downshift by k units, okay? We're going to look at some examples in a couple minutes. What about a left and a right shift? Okay, well, the left shift, just like we did in other things, is going to be the plus, and the right shift is going to be the minus. And it's going to be on the inside of the parentheses with the x. So if we have log base b of, in parentheses, x plus h, okay, so what we have is the plus number is inside the parentheses. It's not on the outside. Over here, it's on the outside. In the up-down shift, it's on the outside. But with the left-right shift, it's on the inside with the x, okay? So if you have an x plus h inside the parentheses, that's a left shift by h units, okay? So if this said x plus 3, it would be a left shift by 3 units. But if you have x minus h on the inside, that's a right shift by h units. So if this said x minus 6, then that would be a right shift by 6 units, okay? And we're going to finish up this video with just a couple of examples. All right, so let's say that we have a function f of x, which is log base 2 of x, okay? And we have this function g of x. And g of x is log base 2 of x plus 5 plus 11. And what we would say here is that g of x is f of x, okay, because look, log base 2, it's the same thing, is f of x shifted. Well, let's look at the shifts here, okay? We have plus 5 on the inside. Remember, with the x, when we have a plus inside with the x, that's a left shift. So this is shifted left 5 units because it's plus 5 units. And we have a plus 11 on the end. And a plus 11 on the end means an up shift. And shifted left 5 units and up 11 units. Okay? All right, let's look at this one here, the second one. It says negative log base 2 of x minus 3 minus 9. Okay? So this minus on the inside means a right shift. And the minus 9 on the end means that that's a down shift, right? And the negative on the front, if you recall, a negative on the front means a reflection across the x-axis. So here, g of x is a reflection of f of x over the x-axis and up shift, or sorry, it's not up, it's down shift. It's minus 9 here, and down shift by 9 units, and x minus 3 means a right shift, and right shift by 3 units. Okay? And what about this third one here? Okay? This third one, g of x, why don't you pause the video and try and figure this one out on your own? All right, so we have log base 2 of negative x. Now notice we don't have a plus or minus with the x, so there is no left or right shift. But because this negative is inside with the x, that means that this is a shift across the y-axis. This is a sideways shift. It's shifting from here over to here, okay? So this is a shift across the y-axis, and then we have a plus 6, so that's up 6, okay? And so this is a reflection over the y-axis, and it's shifted up 6 units. Okay? And that's it for the graphs of logarithmic functions.